unknown exoplanets, but also stars, nebulae of all kinds, black holes, different galaxies, as well as dark matter and dark energy were to be investigated and deciphered in detail with the help of the Hubble Space Telescope. In order to achieve these ambitious goals, Hubble was to work not only in visible light, but also in the electromagnetic spectrum, in the infrared range, and in the ultraviolet range, and to produce revealing images at a resolution never before seen. Shortly after the Space Telescope was moved to its intended position, however, it became apparent that the stars were not aligned for this mission. A failure of the primary mirror resulted in the first images captured by Hubble being virtually unusable. It would take several more years and several repair and maintenance missions before the Space Telescope was able to pursue its original goals without interference. Let us therefore now take a look at those cosmic mysteries that Hubble has already been able to detect. Crab Nebula. The term supernova refers to the brief, extreme illumination of a massive star that is annihilated by an explosion at the end of its lifetime. The luminosity of the star can reach millions or even billions of times its original intensity at this point, making the dying celestial body appear as bright as a full-grown galaxy for a short time. While at the end of a supernova of massive stars, compact objects like black holes or pulsars are formed, lower mass specimens of the glittering bright celestial bodies are literally torn apart by the onset of carbon burning. Thanks to the observations of the Hubble Space Telescope, we have already gained many valuable new insights into cosmic stellar deaths. The example of the Crab Nebula, which occupies an area in the constellation of Taurus, illustrates how revealing the images provided by Hubble are. More precisely, they are the relics of a supernova observed as early as July 1054. As a result of the associated brightness burst, the object became the second brightest astronomical object in the daytime sky. In the meantime, a so-called pulsar wind nebula has formed in the remnants of the supernova. This refers to a stream of high-energy particles generated by the extreme conditions prevailing in the immediate vicinity of a neutron star. The nebula in question is still expanding unceasingly, expanding by almost 900 miles within a single second. The center of the Crab Nebula is again the pulsar that was created in the course of the supernova. As is typical for neutron stars, this celestial body also has a rapid self-rotation rate. The object rotates 30 times around its own axis per second. Hubble Ultra Deep Field rotation rate in the pulsar that was created in the course of the supernova. As is typical for neutron stars, this celestial body also has a rapid self-rotation rate. The object rotates 30 times around its own axis per second. Hubble Ultra Deep Field. The famous image known as the Hubble Ultra Deep Field, or HUDF for short, proves that the Hubble Space Telescope can even give us a glimpse into the most remote regions of the firmament. The image, taken from September 3, 2003 to January 16, 2004, was for a long time the deepest image of the universe in visible light. The spectacular image shows a section of the constellation Fornax, which lies southwest of Orion. Although countless fascinating astronomical formations present themselves in an exuberant variety, the HUDF actually represents only a 40 millionth of the entire sky. In the core we see, besides many other large cosmic objects, about 10,000 galaxies, with the light travel time of these remote regions to us being a whopping 13 billion years. In other words, this means that the image taken by Hubble gives us a direct glimpse into the early days of the universe. Consequently, the image, which depicts the cosmos some 800 million years after the Big Bang, shows some of the first galaxies to develop immediately after the so-called Dark Ages. Deciphering galaxies. After Edwin Hubble came to the realization that the universe was home to countless galaxies other than our own Milky Way, he divided the large gravitationally bound collections of astronomical objects into 3 distinct categories based on their shapes: irregular, spiral, and elliptical galaxies. Through the studies of the Hubble Space Telescope, it was possible to decipher some of the characteristics of these different types of galaxies, which had previously been cosmic mysteries. For example, we now know that the centers of most galaxies are graced by supermassive black holes, which play significant roles in the formation and evolution of these gigantic constellations. To understand how important the findings provided by Hubble are for terrestrial research, it's worth taking a look at Messier 87. This is a giant elliptical galaxy located about 55 million light-years from the Milky Way. In April 2019, scientists were able to confirm the existence of a supermassive black hole at the heart of this galaxy. Moreover, the experts found out that a high-energy jet at least 5,000 light-years long is ejected from this gigantic gravity monster, whose mass is 6.5 billion times greater than that of our Sun. Discoveries of the gravitational lensing effect. In the world of astronomical research, the term gravitational lensing refers to the deflection of light by large masses. Basically, the light from a distant source in the universe, such as that from a star or galaxy, is affected by an object that lies in front of the corresponding sources for the observer and is called a gravitational lens. In its exploration of the cosmos, the Hubble Space Telescope also makes use of technology that takes advantage of this very effect. It's partly thanks to the gravitational lens effect that we have already been able to catch a glimpse of the most distant star ever. This celestial body is optically magnified by the gravity of the galaxy cluster MACS J1149 plus 2223 and classified as a blue supergiant. The exciting object is located more than 9 billion light-years from our terrestrial home. Impact on Jupiter. The comet Shoemaker-Levy 9 was discovered in 1993. It can be assumed that the natural astronomical missile, which had an average diameter of almost 3 miles, was captured. B9 was discovered in 1993. It can be assumed that the natural astronomical missile, which had an average diameter of
نفس الشكل اللي بيظهر عليه رأس وذيل النجم ذو الذنب.
Astronomical missile, which had an average diameter of almost 3 miles, was captured by the strong gravitational forces of Jupiter as early as the 1960s. So, after the comet was forced into a strongly elliptical orbit around the largest representative of our planetary system, it passed the gas giant in the early 90s within the Roche boundary, whereupon it broke up. This criterion, named after the French astronomer Edouard Albert Roche, compares the gravitational forces that hold an object together internally with the tidal forces that pull it apart. Within the Roche limit, the body can no longer withstand the forces acting on it and begins to disintegrate. This was also the case with comet Shoemaker-Levy 9. It broke into 21 fragments between 165 and 3,300 feet in size, which accumulated along a chain 1 million miles long. In July 1994, the fragments of the spacecraft finally slammed into Jupiter's southern hemisphere.
يعني في وسط الزحمة زي ما بيقولوا بيظهر بهذه الوجهة، وحتى هنا شوفوا كاتبين بيقولك إنه صوراه في نصف الكرة الجنوبي، يعني في الناحية الجنوبية بيظهر النجم الطارق أسفل المجموعة الشمسية بالكامل.
Jupiter's southern hemisphere. In the process, the Hubble Space Telescope succeeded in directly observing such an event for the first time in history. The sheer magnitude of the forces released by the impacts becomes clear when we consider that the fragments hurtled towards Jupiter at a speed of 36 miles per second, releasing energies of 650 gigatons of TNT, or 50 million Hiroshima bombs. As a result of the impacts, a dark structure the size of the Pacific Ocean formed on Jupiter. Important findings about exoplanets. While people knew practically nothing about those planets outside our solar system in past centuries, hundreds of these alien worlds have already been identified through the use of highly modern detection methods. Hubble was the first space telescope to comprehensively study the atmosphere of one of these exoplanets, specifically that of the celestial body HD 209458b. In 2003, Hubble determined that the corresponding atmosphere contains oxygen and carbon in the form of methane and carbon dioxide.